Hey, welcome back. We're here for part two of geometric sequences and series, and this is actually where we're going to talk about the series part. The geometric sequence part was just the numbers, multiply or multiply by point something or multiply by 2 each time. That was defining my geometric sequence. Again, a series, as I talked about last time, a series is where you sum up a geometric sequence. So when I start adding up a sequence, it becomes a series. And so I can find, they have two related formulas for me. Here's one that I can do. If I want to find the sum of the first n terms. So your key ones here is if you see something that says, hey, find the sum of the first 8 terms. Okay, if you see that, you want to use formula 1. Why? Because they're probably going to give you an example of the first few terms of the sequence. And so they'll give you the first term, which is here. You're going to be determining the rate. That's easy enough to do. The second term divided by the first term. Piece of cake. Now in the second one's asking for more specific information. They won't say how many terms it is. They will just give you, in this one here, let's change colors because I like colors. I would say, hey, given a sub 1, a sub n, and r, find the sum of the terms. That's it. They'll give you the first term, the last term, and the rate. Okay? So they might say, instead of a sub 1, they might say first term. Instead of a sub n, they might say last term. Okay, and instead of r, they might say rate. Okay, they'll give you those, or not rate, excuse me. That was last time, ratio. They may give you those, and they'll say that, and that's when you'll use formula 2. All right, so let's go ahead and take a look at some examples. So it says here, find the sum of the first 11 terms of this geometric sequence. So again, in your mind, you have to be deciding which one am I going to use. Now on a test or a quiz situation, you'll be given the formulas. You won't be given which one to use when. So that's what you need to know. When do I need to use this one? Which one do I need to use? So after looking at their notes, we see that we would like to use that first formula. So the first thing I need to do is I need to find my rate, or my ratio. So my ratio, or which is r, I'm going to go ahead and say, hey, second term divided by first term. Hit the handy dandy calculator if you don't know it. Negative 1.5. And then I go and grab that first equation. And I start filling in. So if I want to find the sum of the first 11 terms, it's going to ask me for the first term, 4, times 1 minus my common ratio, negative 1.5, raised to the 11th power, because I'm looking for the first 11 terms, all over 1 minus my common ratio. And I can put that into my calculator. A little bit at a time, all at once. If you can, if you're really good at mastering all the parentheses that you need, if you're going to do it all at once, you got to make sure you add the extra parentheses here and here, and you could be able to pull it off. And upon hitting the magic buttons that are on your calculator, you'd be able to see this is a sum of 139.996. Okay. Again, not too difficult because you're given the formulas. You just need to know which formula to pick and what goes in each formula. Let's see the other example. So part B is here. Find the sum of the first n terms of a geometric series with, hey, there's a sub 1, a sub n, and my common ratio. Oh. So again, which one do I choose? hopefully you should go up there and take a look. Oh, I want to choose that second formula. And I start filling it out. I don't know how many terms there are, so I'm still going to keep it as the sum of the first n terms, because I don't know what it is. But what I do know is that it asked me for the first term. Well, that's -4, minus the last term, -65,536, times my common ratio, 2, all divided by 1 minus my common ratio, 2. Again, put that all in my happy calculator. Again, if you're going to put it all in at once, make sure you add the extra parentheses, because your calculator will not be able to handle all the, the multiplying, subtracting without being told where goes where. And upon hitting my magic number, I get a -131,068. Okay. Again, it's not difficult. The hard part is choosing which one to do. Okay. So here's what I want you guys to do. On this next example here, I want you guys to take a look at this one. Choose which one to do. Okay. You should be able to find your common ratio if you need it. And I want you to set up the equation. You don't have to find it, because I know your calculator on your phone may not be able to do all the fanciness that I needed you to do, but I want you to set it up to that first part where the calculator magic happens. Okay? So all I need to do is pause me right now. Bada bing. There's your answer. As far as what you should be able to pull, you should have seen you been able to pull off where the common ratio was 36 divided by 8, or a 4.5. You should have been able to see here that set this all up, knowing that you had the information enough to use the first formula. And then upon pushing the happy buttons in your calculator, once you get to class, you'd be able to see that this was 384,343.438. There we go. Again, not difficult. You should have been able to pull that off. Okay? And if you didn't, talk with me. Ask me questions when you get to class. So this is great, but hey, how do we do with this one? Summation. Hey, remember this? Okay, this isn't as hard as it looks, right? Why? Because we have a really great calculator. And you have to just remember that it's hitting math 0. If you hit math 0 on your calculator, you're going to be able to get all this, and you just plug it in the way it looks. And so you would plug it in, your little happy dandy calculator would pull this up. You would write in n equals 3 to 8. It would have the extra parenthesis, and you would want to make it look like this. And that's what you'd want it to look like. And upon hitting the magic enter button, you would see this as being 168. What I do want you to be able to pull off as well is you're going to be able to need to know what this is. This right here is my formula. In fact, this right here is the explicit form of my geometric sequence, excuse me. So that's my explicit form of my geometric sequence. So there's some information that you need to be able to pull from here that's very, very important. First one is that right there. That's your first term. That's a sub 1. This right here, that's your rate, or your ratio, excuse me. That's your common ratio. You need to be able to identify those. Okay? They may give you the sequence or the formula for the explicit form, and they may be able to say, hey, what's the common ratio? Or hey, what's the first term? And you should be able to, this would be like no-brainer. This is what you got to be able to pull off. You got to be able to say, that's it. There it is. Okay? So what I want you to do in this next one, so I'm going to come over here, and what I want you guys to do in this one is I want you to identify, okay, identify a sub 1 equals, and I want you to, what's my R? Equals. All right, I'm going to pause the video. You guys need to pause the video. So can you pause? Pause. Yes, please pause. Thank you. Bada bing. Did you get the answer? Again, not difficult. Just need to remember what it looks like. Where's my explicit formula? You know, where's my first term? Where's my rate? Excuse me, ratio. I keep saying rate. All right, there's my common ratio. All right, so next is, so we dealt with indefinite terms as a series. Okay, so what happens when I want to add up infinitely many? Well, much like there was a convergent and divergent, arithmetic sequence, there are convergent and divergent geometric sequences. Okay, and series, excuse me. So a sum of an infinite geometric series, okay, so this right here is the same thing as saying sum of infinity, okay? I can only use when the absolute value of my rate is less than 1. Ratio. If my ratio or common ratio is more than 1, I can't use this because my sequence is divergent and I will not have a series or a sum that will converge to a number. My series will not converge. My common ratio needs to be less than 1. So when I take a look at this next one, again, it says, if possible, find the sum of this infinite geometric series. So again, what do I need to know in order to find out if it's possible? So the first part of being possible is I need to find the common ratio. And my common ratio, again, second term divided by first term. I go ahead and type that in the calculator. Beep, boop, boop, boop. And I go ahead and I get this to be 0.75. Or, if you can automatically do it, it's 3/4. That's my common ratio. I multiply each one by 3/4, or 0.75. So then I apply the formula. My formula said, hey, it's S is equal to 24, the first term, divided by 1 minus my common ratio, 0.75. I put that into my happy calculator, and I get 96. So what's really, really, really cool about that, you got to think about this, how mind-blowing this is. If I add up 24 plus 18 plus 13.5 plus blah, da, 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 I have infinitely many things that I will add up. Infinitely many things that I add up. You will never stop adding. I know that my answer is going to be 96. Right? Mind-blowing. All right. So what about the next one? Again, it says, if possible, find the sum of the infinite geometric series. 0.33, 0.66, 1.32. Hey, those are small numbers. And here, if I go ahead and I find my rate, second one, 0.66, divided by the first one, 0.33. Put that in my calculator. It tells me 2. Is that less than 1? I hope not. I hope you say no. Okay. So on this one, even though the numbers seem small, 0.33, 0.66, 1.32, okay, they keep getting bigger and bigger, and this series is divergent. Okay, it will never converge to a specific number. So I say it is not possible. Okay, last example. It says, if possible, find, the sum of this one. So what's different about this one? take a look. First off, can I identify my rate? Can I identify my rate? Yes. It's right here, right? That's what you have. This is not my rate, my ratio. There's R. And so you may be thinking to yourself, hey, self, I got this. This is not a problem. Okay, there's my ratio. Okay, this right here, what's this one? That's my first term. Okay, so I'm going to take my sum of my infinitely many terms. Yes, it is possible. Why? Because my ratio is less than 1. All right, so I come out here and I go, this is equal to 3 divided by 1 minus 0.65. Okay, equals, and then you get down here, 8.5714, dot, dot, dot. And if you're really good, okay, you'd find out this is actually equal to 8 4/7. Okay, remember that math 0, 0. If you hit math 0, 0, it changes a decimal to a fraction. Do that from time to time. Your decimal may actually be a specific fraction. And you go, done! I'm done! Woo! All right, skip, next problem. And this is where I would say, you need to be careful. Why do you need to be careful? Looky, looky. It's not asking from the first term on. It's asking from the second term on. This includes right here is a sub 1 plus a sub 2 plus dot, 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 dot. I don't want that. What do I want? I want a sub 2 plus a sub 3 plus dot, dot, dot. That's what I really want. Oh. So if I take away a sub 1, I should be okay. So if I take away this 3 from this, that is my actual answer for this problem. Okay, so we need to be careful. That's the end. I hope you enjoyed it. Your work is going to be based off of all these, so hopefully you get it and understand. I'll see you guys later. Bye.